The NeuroGov Plus 63 engine architecture can be used across different enterprise domains. The strength of the 63 engine architecture is that the core engines remain the same, while the business logic, KPIs, policies, and domain-specific rules change. This means the architecture is reusable across multiple industries without redesigning the governance framework. 1. Healthcare, HMIS-GPT. Purpose: deliver governed patient care, hospital operations, and clinical decision support. Domain-specific engines. Patient registration. OPD/IPD. Laboratory. Pharmacy. ICU. OT. Radiology. Nursing. Billing. Insurance. Infection control. 63 engines help monitor patient flow, detect clinical risks, optimize bed utilization, reduce waiting time, improve treatment quality, ensure NABH/JCI compliance, support hospital governance. 2. Finance GPT. Purpose: govern financial operations using AI and policy-driven decision-making. Domain examples: accounts payable, accounts receivable, general ledger, treasury, budget, cost control, cash flow, asset management, taxation, financial closing. 63 engines help detect fraud, predict cash shortages, monitor financial KPIs, improve compliance, reduce financial risk, support CFO decisions. 3. Hermes GPT. Purpose: govern workforce management. Domain examples: recruitment, payroll, attendance, leave, performance, learning, succession, compliance. 63 engines help predict attrition, identify skill gaps, workforce planning, employee engagement, HR compliance, performance governance. 4. Manufacturing GPT. Purpose: optimize production using governed intelligence. Domain examples: production, quality, maintenance, inventory, planning, procurement, logistics. 63 engines help predict machine failures, improve OEE, reduce scrap, improve quality, optimize production scheduling, support plant governance. 5. Supply chain GPT. Purpose: govern end-to-end supply chains. Domain examples: warehouse, procurement, inventory, transportation, vendor management, distribution. 63 engines help inventory optimization, vendor evaluation, shipment prediction, risk analysis, supply chain resilience. 6. Education GPT. Purpose: improve institutional governance. Domain examples: student admissions, attendance, faculty, examination, learning management, accreditation. 63 engines help student performance prediction, faculty workload analysis, academic governance, accreditation readiness, resource optimization. 7. ESG GPT. Purpose: govern sustainability initiatives. Domain examples: environment, social, governance, carbon emission, waste, water, energy. 63 engines help ESG scoring, compliance monitoring, sustainability reporting, risk management, carbon reduction planning. 8. Retail GPT. Purpose: improve customer experience and retail profitability. Domain examples: sales, inventory, Customer loyalty. Pricing. Promotions. 63 engines help. Demand forecasting. Customer segmentation. Promotion optimization. Stock replenishment. Margin improvement. 9 Pharma GPT. Purpose. Govern pharmaceutical manufacturing and distribution. Domain examples. Batch manufacturing. Validation. Quality assurance. Regulatory. Laboratory. 63 engines help. Batch quality prediction. Compliance monitoring. GMP governance. Recall management. Quality improvement. 10 Smart City GPT. Purpose. Govern urban operations. Domain examples. Traffic. Water. Electricity. Waste. Public safety. Citizen services. 63 engines help. Traffic optimization. Utility monitoring. Emergency response. Resource planning. Citizen service improvement. 11 Banking GPT. Purpose. Govern banking operations. Domain examples. Loans. Deposits. Treasury. AML. KYC. Risk. 63 engines help. Credit risk analysis. Fraud detection. AML compliance. Customer intelligence. Regulatory governance. 12 Insurance GPT. Purpose. Govern insurance operations. Domain examples. Claims. Underwriting. Policy administration. Customer service. 63 engines help. Claim fraud detection. Risk prediction. Premium optimization. Faster settlements. 13 Government GPT. Purpose. Support transparent public administration. Domain examples. Citizen services. Revenue. Tax. Health. Welfare. 63 engines help. Policy governance. Service optimization. Budget monitoring. Transparency. Audit readiness. 14 Telecom GPT. Purpose. Optimize telecom network and customer operations. Domain examples. Network. Billing. CRM. Customer care. 63 engines help. Network optimization. Churn prediction. Service quality monitoring. Revenue assurance. 15 Enterprise-wide governance. The same 63 engines can coordinate multiple domains simultaneously. For example, 63 engine architecture. Enterprise governance brain. HMIS finance HR manufacturing. Retail ESG education pharma. Supply chain banking telecom. One governance platform. Every domain uses the same governance principles while applying its own business rules, policies, and performance metrics. What changes between domains? Component common across domains changes by domain. 63 engines no. Architecture no. Closed loop engineering trademark no. AI memory no. Analyzer 1.0 no. Policy engine policy rules. KPIs framework KPI definitions. Data model framework business entities. Q&A framework domain knowledge. Dashboards framework visualizations. Power summary. The 63 engine architecture serves as a reusable enterprise foundation rather than a single domain solution. Its governance, assurance, memory, and continuous improvement capabilities remain consistent, while each industry customizes the data, policies, KPIs, and workflows relevant to its operations. This approach enables organizations to build a family of domain-specific platforms such as HMIS GPT, Finance GPT, HRMS GPT, Manufacturing GPT, Education GPT, ESG GPT, Supply Chain GPT, Pharma GPT, Retail GPT, Banking GPT, Insurance GPT, Telecom GPT, and Government GPT, all on a common governed AI architecture. The result is a consistent governance model with domain-specific intelligence, making it easier to scale across the enterprise while maintaining transparency, accountability, and continuous learning. About Dr. Pradeep K. Suri, architect of the 63 Engines Reusable Enterprise Architecture. Dr. Pradeep K. Suri is an enterprise architect and technology practitioner whose work focuses on designing reusable, governance-oriented enterprise architectures that can be applied across multiple business domains. Rather than creating separate solutions for each industry, his work emphasizes a common architectural foundation that can be configured for different organizational contexts. The central idea behind the 63 Engines architecture is to decompose enterprise intelligence into a set of specialized engines, where each engine has a clearly defined responsibility. This modular approach aims to improve maintainability, consistency, and reuse across enterprise applications. Instead of viewing AI as a single decision-making component, the architecture organizes processing into multiple layers that can include data preparation, analytics, governance, decision support, auditability, memory, replay, visualization, and management reporting. Each engine contributes to a specific stage of the enterprise workflow. A key objective of the architecture is reusability. Rather than building independent systems for finance, healthcare, manufacturing, education, logistics, or human resources, the same architectural engines can be adapted to different domains while preserving a common governance framework. The architecture is intended to separate domain-specific business rules from the underlying enterprise platform. This allows organizations to extend the same foundation into multiple operational environments without redesigning the core architecture. Another characteristic of Dr. Suri's approach is the integration of operational data with governance-oriented components. In this model, business metrics, analytical results, policy evaluation, management recommendations, and evidence generation are connected through a structured processing pipeline. The architecture also places emphasis on explainability. By assigning responsibilities to individual engines, enterprise users can better understand how information moves through the system, how recommendations are generated, and where governance decisions are applied. Across different industries, many business functions share common requirements such as monitoring, reporting, workflow management, audit trails, compliance, decision support, and performance measurement. The reusable engine concept seeks to address these shared requirements with configurable components instead of isolated implementations. The modular design can support expansion over time. Organizations may adopt only the engines required for a particular implementation and introduce additional capabilities as operational needs evolve. Another aspect of the architecture is its emphasis on enterprise visualization. Dashboards, hierarchical views, knowledge relationships, performance indicators, and management summaries are intended to present complex enterprise information in a structured manner for different organizational roles. The architecture is also designed to support iterative improvement. Enterprise feedback, operational observations, governance outcomes, and performance measurements can be incorporated into future refinements of the overall system design. Dr. Suri's work reflects experience across multiple enterprise environments and seeks to combine enterprise architecture practices with AI-enabled decision support and governance mechanisms in a unified framework. Although organizations differ in processes and regulations, many foundational architectural requirements remain consistent. The 63 Engines concept attempts to leverage these common patterns to reduce duplication and encourage reuse across implementations. From a management perspective, the reusable architecture can help establish greater consistency in enterprise reporting, governance, and operational visibility while allowing domain-specific customization where necessary. Ultimately, The 63 engines architecture represents a modular enterprise engineering approach, a common architectural foundation that can be configured for diverse industries while maintaining consistency, scalability, and reuse. Summary. The 63 engines concept proposes a reusable enterprise architecture in which specialized engines perform distinct functions within a larger enterprise ecosystem. The same architectural framework can be adapted across multiple domains by configuring business-specific rules while preserving common governance and operational capabilities. Dr. Pradeep K. Suri's contribution lies in promoting a modular, reusable architectural approach that emphasizes structured enterprise processing, governance integration, explainability, and long-term extensibility rather than building isolated, domain-specific systems from scratch. Power summary. The vision behind the 63 engines architecture is not to create one solution for one industry, but to establish a reusable enterprise foundation where specialized engines can be configured for multiple domains. By emphasizing modularity, governance, and reuse, the architecture aims to provide a consistent framework that organizations can adapt to their own operational requirements while evolving over time. This description characterizes the architectural goals and design philosophy without making claims about external validation or industry adoption beyond what has been established. Dr. Pradeep K. Suri. Thanks for watching the video.